We're in the advanced steel platform and we're taking a look at GRAITEC stairs and railings, and in particular we're looking at the railing ending types and the arrangement of these controlled within the ending panel here. So first of all, you would need to look at the ending type. So here you can see that in here we have a tree structure arrangement, and this actually controls each individual element within the rail itself. So the first thing you would need to do is you would need to set what is required. So typically if you select at the top level here, if you expand that out, you can see there's a start and an end detail. And within the rail, that means there's a swan neck at the start and a swan neck at the top, obviously on the top handrail element. And similarly, each one of the middle rails is controlled in a similar fashion. By here, expanding the tree, you can see here middle rail, and it's slightly deeper here because we obviously have two middle rails at the start and the ends. Okay, so and we can set individual elements to do at each end. So here for element 1, so that's rail 1, that would be the bottom one here, we have a swan neck. Rail 2, we have a swan neck here for the middle rail. If we go to the end, we can see it's set to none. So here we don't have any at all presently turned on, so the rail is actually stopping at the end point that was selected at the rail creation. But for example, if you did want to put one on, you could put it on individually on an individual rail, and it will put in a default arrangement. The same applies at the bottom as well, at the start of the stair. It will come in with some parameters and create something. Similarly, if you wanted to apply it to both, you could actually click in there and it will actually apply it to both mid rails. This functionality is common throughout the macro. So I'm just going to turn that off because we don't actually want to put that on just at the moment. So just go back, toggle that, turn it on and off, and make sure you're in the end detail. So just coming back down in the example that we have here. So typically the railings will be set out to measurements. Normally there'll be a maximum gap depending on the regulations. And personally, if I was trying to do this, I would create a few construction lines to get some idea of some of the measurements that I might need to achieve this, and just check what I'm doing. So here, for example, looking on the front of the rail, I know that the bottom rail would need to be, say, 100 millimeters to the underside edge above the floor level or the base of the landing. And being as the railing always works out to the center line or the system line, which is in the middle position, I know that I need to achieve a dimension of 105 for that. Similarly, at the top here, I have the same sort of problem. I need 100 millimeters gap between the top rail and the middle or shadow rail. So for that, I know that I need 110 millimeters to get between the two center lines stroke system lines. Similarly, if I wanted to offset here and I want to return my rail round, I'd probably need to know the position of that relative to the nosing point. So again, I may have some indicative construction inside the model, or I would actually create some dimensional elements here with some basic lines just to give me those turn points. The other important thing to watch out for is actually when you create a rail, you can obviously see that here this is the top of it, and this line here is the middle of it. Now, although this is a curved element in here when it's been turned into a swan neck, if you were to miter this rail, you would see it would be working to this middle point here. And correspondingly, where the vertical step element is as you come down through the rail here, so this bit in here, where it comes down, at the bottom, this line is obviously in the middle of the horizontal element returning here. So obviously, this is a critical measurement. And I would advise, as I said, to create some construction so you can actually see what that figure is. And this will actually then correspond back to give you the right figure over here. So if we just change tabs here and go to the ending tab, and if we go to the middle rail, so obviously because it's all different, if you click in there and say it's all different and you can't actually do it, one of the obviously child relationships is different to the parent. So what we're going to do is we're just going to go in here and look at this. So obviously rail 1 is typically the bottom here, the lower rail. Rail 2 will be what I term the shadow rail. Now, how is this being controlled? The first thing I would look at here is obviously my bottom rail here is clashing with my nosing position. So I may want to adjust that slightly. So again, I would come into rail 1 and maybe I adjust the position, and that would be actually L here, which will actually move this over. So by typing a figure in here, I will move the vertical section over to the left, and correspondingly that moves over the rest of the bottom rail. So as that moves that over, we can see everything else is extended. Now you may have some misalignment up here. That's because this horizontal leg length is now 200. So that's actually this base measurement in here between centers. So we're going to cut that back to 150. So by adjusting that, it'll pull the sidebar back and a couple of infill bars back to that position. Now, what you can do is obviously sometimes you end up in situations which are not particularly nice for fabrication. So obviously trying to bring an infill bar down into that position is not going to be very easy for the fabricator to make. So obviously during the design process, you might consider making a further change. So you would come back in here and you would adjust this in here. So if we extend that out by 100 rather than 50 millimeters, it will move across, and we just take that back down in here into 100 instead of 150, and it'll pull it back to the right. So effectively we end up in the same position, but all we've done is adjusted it slightly. And as we adjust it, you can see that the infill bars recalculate their positions. So just while we're talking about that, let's just pop up to the shadow rail at the top. So similarly, we can see here that we've not decided to offset it from the nosing position. That's because obviously we need enough room to get the top rail around the corner, and we've only got a couple of 100 millimeters. So we've obviously offset the top rail out by 100 mil, allowed for the bends to form the shape and a little bit of straight to come out on the end, and then a butt joint back here. So a little bit of that sort of sets our determine our basis of our returns. But obviously the second rail, if we could move this over and it will close the gap down to 75, but we'd like to try and keep it flowing and looking the same. So we're going to leave it 100 millimeters. So in this case, we have not put any offset into L. But then what we can do is we can start to look in here. So we've still got 200 millimeters in here for the horizontal length. So that is actually from the start line to this center line over here. So that's 200 millimeters. So effectively the return ends up in the same place on the center line as it turns around the corner. So this effectively gives you the horizontal setting out, and then obviously, as I said earlier on, you need to start looking at the vertical setting out. Now obviously we want to achieve 100 millimeters in here, the same as we have done elsewhere. But what happens is, as the angle of the rail changes, normally from the staircase, this point will actually move and adjust. So if you were to change the angle of the stair, the actual intersection point would change there. Now, the only way that I've ever found to do this is to actually put this figure in correctly to actually get what you need. And this is actually the vertical measurement. So if we remain in the shadow rail position, so this is position number 2 of the middle rails, we can see here there's a height value on here. At the moment it's set to 200 millimeters. So for example, if I was to actually take that down to 150 millimeters, you'll see this section of the rail reduce and the middle rail move up. This will close the gap down in here and obviously extend the infill bars below. Now that looks fine. It hasn't moved horizontally, it's just moved vertically. But obviously this gap is now too small. But you can see that I'd already calculated where it should be from a couple of simple setting out lines. So I'm actually going to transpose that figure into the dimension field here. Just type that in the dialog box and allow the macro to recalculate the swan neck, and you'll see the vertical section will now increase and the shadow rail will drop down and the corresponding return bar. Similarly, we now have to come down and consider the bottom. Now at the moment this is probably using a standard vertical height of 200 mm that's put in by default. So again, we want to achieve a measurement to the center of the rail of 105, 100 mm clearance below. So again, we need to draw a couple of lines just to make sure we get the right intersection point for the middle of the rail. and get the right reference point here. So similarly, we had done that, created a dimension, and obviously now we know what that dimension should be, and we can correspondingly put that into this field. So again, by entering the measurement into the cell, we'll now see the bottom rail now pull up and the vertical section decrease. Obviously the horizontal does not change, but now we end up with the rail exactly where it should be. Similarly, obviously you can take a look at the sidebars. Obviously the sidebar is enabled, it's going off to the left. Obviously it's set to a butt joint in here. You can change it to a mitre if you want, depending on what you want. You can have a bend if you would like a bend. You can obviously change from right to left as well. And similarly, this can be independently controlled depending on which level you want to be in. So being as we want them both to be the same, we could go to the top level or another level in the branching of the tree, and we can change this in here. And I'm just going to change this to 250 mil, and you'll see it extend out. I wouldn't say that you actually need to do that. I was just demonstrating it because obviously now they don't line up. So we're just going to pop that back to 200. And as we're doing this, you're seeing that the infill bars are adjusting. Now, actually, the infill bars are part of the Swan Neck, but they're not actually controlled within the Swan Neck dialog. So you just need to change the main tab here to go to infills. Obviously you're on pickets, and come down into the properties tab, and you just need to check this here, create pickets at railing start. If I uncheck that box in there, the pickets will be turned off. So with them turned off, you can turn them back on again just by checking the box. You can obviously create the rail without the pickets on and the swan necks as well separately, but sometimes it's nice to see where the pickets are being formed to avoid issues of them clashing with the various bent or vertical members. So that's a very quick insight into how to use the Swan Neck feature within the GRAITEC stairs and railings. Thank you.